Hi, my name is Carlos Araujo and along with Sofia Martinez and Cecia Portillo, we're going to teach our cookie friend how to solve a right triangle and how to use vectors properly in a coordinate plane. Now let's start with the information. Right now we're going to start with section 9.7, which is called vectors. First of all, we're going to define what we're going to do in this section. Part 1, finding the magnitude and describing the direction of a vector. Here is a really important vocabulary you need to know for you to determine and do things in this section. Vector, quantity with a magnitude and a distance. Magnitude of a vector, the distance from an initial point A to the terminal point B. And direction of a vector, determined by the angle that vector makes with a horizontal line. Part A, finding the magnitude of a vector. A vector is often called the absolute value of vector AB. If written in a coordinate plane or graph, a vector can be calculated using the distance formula, which you can see right here. The 1 implies the initial point, and the 2 implies the terminal point. That means that the letters that have a Y should be the values that represent the initial point, and the same goes for 2. Example number 1. Find the magnitude of this vector. The vector that we are going to find is this one that you can see on the graph. It has an initial point 1,3 and a terminal point 5,6. The first step is to identify the initial or the terminal points of the vector. We already do that. So the next thing to do is to input the values to the distance formula and solve. You should do it as shown in here and do the procedure until you get the distance of 5. That means that the magnitude of this vector is 5 units to the north. Part B. Describing the direction of a vector. The direction of a vector is described relative to the directions north, east, south, west, or a combination of each. The x-axis can be considered the east-west line, and the y-axis could be considered the north and south line. You can describe it by finding the measure of the angle made by the vector and a horizontal line, finding the opposite and the adjacent side in a right triangle, putting them into a fraction. Opposite side is numerator, and getting the inverse tangent for this fraction. This is a measure of the angle. Depending on the sided points, that is the relative direction. Example number 2. Find the direction of a vector. First of all, draw the horizontal and vertical displacement of the vector shown in this Cartesian plane, and also draw the displacements as shown, in a way that the vector is the hypotenuse of a right triangle. In this case, the legs of this right triangle are both 2. Now, create the equation involving the inverse of a tangent. Tangent of x is equal to the opposite, meaning the vertical line, to the adjacent, meaning the horizontal line. Then just complete the process and you will get that x is equal to 45. Then the direction of this vector is 45 degrees northwest.
Two vectors are equal if they have the same magnitude and direction. Both of these vectors have a component form of 3,5. Two vectors are parallel if they have the same or opposite directions. These two vectors are positive and this one is negative, but they are still parallel. Two vectors can be added to form a new vector using this formula, and the vector u and its component forms, and the vector b with its component forms. Here's an example. Using the vector u and its component form of 3,5 and the vector b with its component form of -6, -1, you can draw the lines and then do the process. Just put in the values in this formula and solve it. 3 plus -6, 5 plus -1 gives you -3,4. And you can add the last line, that's -1, 2, 3, 1, 2, 3, 4. Atención.